Our next topic is total energy, that is total energy. This energy is written by E. We know that total energy is sum of kinetic and potential energy, where T is called kinetic energy and U is called potential energy. So this is the equation for total energy, T plus U. Now what is T? We know that T is kinetic energy and its formula is half mv square, that is half mu r dot square, because in the particle which is moving under central force is considered as reduced body or reduced mass. So half mass is mu, that is reduced mass, and r dot is velocity. So this is half mv square. Now we will put the value of r dot from plane polar system. We know that in plane polar system r dot is equal to r dot r cap plus r theta dot theta cap, this one. When we put the magnitude of this velocity, and it will become, this is r dot square is equal to r dot square plus r square theta dot square. So this is the magnitude of velocity. So we will put this value in this equation, and kinetic energy become half mu into r dot square plus r square theta dot square. This is energy T, and the value for energy total E, it will become T plus U, that is half mu into r dot square plus r theta dot square plus U, this one. This is value of T, and plus U is same. Now solve this equation from the right hand side, and we will get E is equal to half mu r dot square plus half mu r square theta dot square, r square theta dot square, and plus U. So I have multiplied these terms with half mu. Now this is half mu r dot square plus, we will put the value of theta dot here. What is theta dot? We know that theta dot is equal to L over mu r square, because we have already proved it, that is mu r square theta dot is equal to L. I have proved in the previous article. So theta dot is L upon mu r square. So we will put the value here, half mu r square into theta dot square, that is L square over mu square r raised to power 4. This is square of this value, and plus U. Now this mu is cancelled out with mu, and r square is cancelled out with this r square, remaining power is 2, and this one is half mu r dot square plus L square over mu r square plus U. This is total energy. This one is total energy. So this energy contains three terms: first term, second term, and third term. So this is total energy of the particle which is moving under inverse square force. Now next article is conservation of total energy. Conservation of total energy Which energy? Energy of the particle which is moving under inverse square force or central force. So we will prove the energy, total energy is conserved, that is E is constant. Conserve means constant, or the derivative of E with respect to time should be 0. So this is the meaning of conservation of energy, that is E is constant or dE upon dt is 0, because E is constant and the derivative of constant term is always 0. So we have to prove the derivative of energy with respect to time should be 0. How we can prove it? We will prove by using the equation for a particle which is moving under central force. So what is that equation? We have solved that equation in the previous lecture, that is mu r double dot plus L square over minus L square upon mu r cube, L square upon mu r cube is equal to f of r. So from where this equation comes? This equation comes from this, here is negative. This equation comes from the previous article which I have proved it in the starting, that is, it is a combination of both r coefficient as well as theta coefficient. So this one is the equation that is called second order differential equation or RT equation. So I have written this as RT equation or second order differential equation. So this equation, let this equation is number 1. So we will prove dE upon dt is equal to 0 from this equation. So how we can prove it? We will reduce this equation into equation of energy. So how is it possible? So we can make it possible by using derivative. So first of all, this equation may be written as mu r double dot is equal to, this term goes on the right hand side, and L square upon mu r cube plus f of r, this one. Now reduce these terms which are on the right hand side into differential form. So what is the formula for these terms? Since you know that f of r, that is the force which depends upon r, this force is also called conservative force. So we know that the conservative force is that force which may be produced from the scalar function, that is minus du upon dr. Negative gradient of potential energy is equal to force. So this is conservative force, the formula for conservative force. So I will put this f of r as this differential form, this one. And also the second, I will also reduce this term as the derivative of any term. So what is this term? So this term may be written as L square over mu r cube, may be written as the derivative of L square over mu r square. You can prove it. The derivative of L square upon mu r square with the negative sign. So we will get the same answer. So this answer can be obtained by the derivative of this term with respect to r with negative sign. You can solve it. So I will use these formulae, differential formulae on the right hand side, and we will get mu r double dot, this one, and this term may be written as minus ddr of L square upon 2 mu r square, and this f of r is minus ddr of u. So I have changed the right hand side into derivative form, differential form. Now, it may also be written as the minus ddr is common, and this will L square over 2 mu r square plus u. This is, and this is mu r double dot. Now, what is next step? The next step will be, we have to reduce this left hand side also in differential form. So, it is possible if we multiply this term with r dot on both sides. So, we will get mu r dot r double dot is equal to minus ddr of this one L square upon mu r square plus u into r double dot. So, what I have done? I have done the multiplication with r dot on both sides. I multiplied this term with r dot on both sides. Now, what is this? It will become the derivative of ddt of, this is derivative with respect to r, but it will be the derivative of with respect to t. It will half mu r square, r dot square, sorry. So, we may write this term as this. If you solve the derivative of this term, then we will get the same answer. So, right hand side, this r dot may be written as dr by dt. So, this is ddr of L square upon mu r square plus u into dr by dt. So, we may cancel this dr with dr, and we got the final answer. ddt of half mu r dot square is equal to minus d dt, because this is d dt, and the term is L square upon 2 mu r square plus u. Is it clear? Now, take all the terms from right hand side to right hand side, left hand side, and we will get dt of half mu r dot square plus L square upon 2 mu r square plus u is equal to 0. Okay. Now, what is this? This term is constant because the derivative of this term is 0. So, this implies this term half mu r dot square plus L square upon 2 mu r square plus u is constant. And what is this? This is nothing, it is total energy, which I have proved in the previous article. This is total energy. So, total energy E is constant. So, this shows that the particle which is moving under inverse square force or central force, the total energy of that particle is always constant. So, that is conservation of energy. Now, we will discuss the next topic in the next lecture. Thank you very much.